Okay, so the general cubic function. Okay, the general cubic function. We learned like there are two forms of cubic function. The one form is in the point of inflection form, which is a bracket x minus h cubed plus k, which is very similar to the turning point form. And we have another form is the fully factorized form, x minus a times x minus b times x minus c in that form. Okay, so we have two forms of cubic function, and those two forms looks very different. Okay, those two forms looks very different. So for the point of inflection form, we will have point of inflection and we have domain R, range of R. And then for the general equation, we look at h value and k value. That's the movement for the point of inflection, moving to the right, moving up. And then you should remember that the inverse function for cubic is a cube root function. Okay, for quadratic, the inverse function is a square root. Then for cubic function, the inverse function is a cube root. Okay, let's sketch the following inverse function. So you know like there must be one x-intercept and one y-intercept for the cubic function, because we have domain R, range of R. I can take any value of x, I can take any value of y, therefore there must be x, y intercept. And then let's have a look. What's the turning point here? The turning point for this one will be point of inflection will be 4, 2. And when x equals to 0, remember the 2 is not the y-intercept, is the point of inflection. So when x equals to 0, not equals to 2, when x equals to 0, y will equals to 2 times minus 4 cubed plus 2. And then y equals to negative 2 times 16 times 4 plus 2, which is like a really large number. So y equals to, that's 8 minus 1 to 8 plus 2, so it's minus 1 to 6. So that's the y-intercept. And then when y equals to 0, 2x minus 4 cubed equals to minus 2. X minus 4 cubed equals to minus 1. And that's an odd power, so that's still a negative 1. I just have one answer. And then x equals to 3. So I have x-intercept at 3 and y-intercept at negative 1 to 6. Okay, I cannot really sketch it to scale. Okay, just roughly do this. So you have 0.42. Okay, that's the point of inflection. And you have 3, 0, which is the x-intercept. And you have a really large negative number, 0, negative 1 to 6, which is the y-intercept. And let's have a look at this. The a value is positive. The a value is positive. So I will have increasing graph. Okay, increasing graph. So okay, something like that. Because it's not really to scale, so it's hard to sketch. It's like something like that. Okay. Just make sure you need to show the point of inflection. Makes it looks like a point of inflection. Okay. And for the next equation, you should see that it's not in the standard form. In the standard form, the x minus h cubed should be like a single x, no coefficient in front of x. But I have a coefficient of negative 1 in front of x, which is not very good. So that's 3. Let's take minus 1 as the common factor. And then I'll do this. So that is 3 times minus 1 cubed times that cube plus that. So you have a minus 3 x plus 1 cubed plus 3 on 2. So you know point of inflection will be minus 1 and 3 on 2. Okay, point of inflection will be minus 1 and 3 on 2. And it's a decreasing shape of the graph. Okay, it's a decreasing shape because this a value is negative. Okay, because this a value is negative. So when x equals to 0, y equals to minus 3 times 1 plus 3 over 2. That gives you y equals to 3 over 2. When y equals to 0, 3 plus that cube equals to 3 over 2. X plus 1 cube equals to a half. X plus 1 equals to cube root of a half. Okay, if you want to rationalize the denominator, you need 3 2's under the bottom, so you need to times 2 2's on the top. Then x equals to, that's a cube root of 4 over 2, subtract 1. So cube root of 4 is a number in between 1 and 2. Okay, in between 1 and 2. So, and you divide that by a half, so it's in between a half and 1. It's less than 1. So you have a negative x-intercept. This number should be smaller than 0. Because what you have here is, okay, cube root of 4 is a number in between 1 and 2, and you divide that by 2 is a number in between half and 1. And you go to subtract that by 1, so you got a number less than 0. So you have a negative x-intercept. Okay, and a positive y-intercept. Okay, so you have negative 1 and negative 3 on 2. And you have positive 3 on 2. And you have x-intercept is a negative number. Okay, that's a negative number, and it's like a number in between negative 0.5 to 0. So it's about here. Okay, and it's a, what shape of this graph? Have negative 1 and 3 on 2. Oh, wait, it's positive. Negative 1 and 3 on 2. Which is here, and you have negative 3 on 2 here. So the graph looks like this. This is 0, negative 3 on 2. Here is 1, negative 1, 3 on 2, and this point is cube root of that minus 1. Cube root 4 over 2 minus 1. There's 3 point units to show. Okay, that's to sketch the cubic function by using the point of inflection form. It's quite similar to when you sketch it by using the turning point form to sketch quadratic. Okay, so just like, because the number I give you is not very good, it's some like number not very easy to really sketch it. Some decimal, some root numbers. But like I suppose in the exam they can give you some easier numbers like what you can deal with if you don't have the CAS. Okay, and the next one is graph of factorized form. Okay, all of this I will give you to read. That's just sometimes like you forget how to do. You can read back to this. But I'll directly do this question. So to factorize, to sketch some equation, you need to factorize first. Okay, you need to factorize first. If not in the point of inflection form, you need to factorize that. Okay, you need to factorize that and then sketch it. So let's think about how to factorize this one. Ask you to factorize. So you can try number plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So I'll start with 1, 2, minus 5, and 6. Let's try I'll try -1. You have 1, -1, 2 plus -1 is 1, -1 times plus -5, which is -6, -1 times that is 6, but you get 6 plus 6 is 12, which is not working. So let's try 1. 1 times 1, that gives you 3. 1 times 3 is 3, that gives you -2. -2, that gives you 4, not working. Oh, wait, that's a -6. That's why it's not working. That's a -6. So 6 plus -6, which is 0. So -1 works. Okay, -1 works. So fx will equals to x plus 1 minus -1 is plus 1. And x squared plus x minus 6. And you can further factorize that because you have a quadratic now. You have x plus 3 and x minus 2. -6 is 3 times -2, and you want to add them to make it become a +1. Okay, so now what you have is three factors. Okay, 3 factors. And let's sketch all of these x-intercept. What you can see is the x-intercept first. So what can be the x-intercept? When that equals to 0. When that whole thing equals to 0, so it's either this bracket to be 0, or this bracket equals to 0, or this bracket equals to 0. So you will have point -1, -3, and +2. Okay, that's the 3 x-intercept you can find. -3, 0, -1, 0, and 2, 0. So first you find 3 x-intercept. And then, like, if you can see the y-intercept, let's just directly label the y-intercept. Like, y-intercept will be somewhere below here. Oh, I draw it too high. It's okay, let's say -6. You have 0, -6 here. And remember, the graph is not symmetrical between 2 x-intercepts. Okay, the graph is not symmetrical between the 2 x-intercepts. It's not same as the even power function is symmetrical, but for odd power function is not symmetrical. So if it's not symmetrical, like I need to show that it's not symmetrical. Do not draw it like really symmetrical. You may lose mark because of that. And the next thing we need to do is think about the the leading term, the coefficient of the leading term. Okay, the coefficient of leading term is positive. Okay, I will start from the top right. Okay, I always start my graph from the right hand side, and I always start from the top. Okay, if it's positive. If it's negative, I'll start from the right but bottom. So what means top? I'll start from this position, not here. Okay, I will start from like about this area. So if I start from here, like I just go through all the holes. Okay, there are all the holes here. Okay, that is roughly my graph. Oh. Okay, that's like roughly my shape, my graph. And you may ask me, where's this turning point? Is that before the y-intercept or after the y-intercept? I don't know. Okay, really I don't know. You can put it anywhere. Just do not draw like it's a really symmetrical graph, and do not suppose that point will be -2 or something. So that's enough. After you learn the application of differentiation, you can work out the turning point. Like I think you now know how to work out the turning point, but it's not really require you to do that, not require you to label the turning point. Just don't need to worry about that, and just think about, okay, it's roughly there, and just put it there. Okay, and it's like a perfect graph now. I have all the x-intercept labeled, all the y-intercept labeled, and that's it. Okay, so this one is like a fully factorized form. Okay, it's fully factorized for your fx. Okay, so like you have 3 different linear factor. Okay, 3 different linear factor. But let's have a look at the next one. For the next one, it's like repeat factors. repeat factors. Like I want to factorize that. Let's say we have 1, but we don't have x squared term, so it's a 0. And the x term is minus 3, the constant term is minus 2. And I will try, maybe try negative 1, and then that's 1, that give you negative 1, that's 1 plus that negative 2, that's 2 plus 2 give you a 0. So fx will equals to x plus 1, x squared minus x minus 2. So fx will gives you x plus 1, x minus 2, and then another x plus 1. Okay, another x plus 1. Those two give you this quadratic. And you will have x plus 1 squared. You have 2 factors as x plus 1. It's still linear, 3 linear factors, but 2 of them are repeated. Okay, 2 of them are repeated. So if you have repeated factor, okay, if the factor repeat even number of times, so repeat 2 times, 4 times, 6 times, 8 times, that become a turning point. If the factor repeat odd number of times, 3 times, 5 times, 7 times, that become a point of inflection. Okay, at that intercept, that become a point of inflection. Yeah. Oh, I leave 2 small spaces. So I will have x-intercept at minus 1 and positive 2. Have x and y have minus 1 and positive 2. Okay, minus 1, positive 2. But minus 1 is the repeated factor. The minus 1 is the repeated factor. So you will have turning point here. Okay, just label a small turning point. You just know that point will be a turning point for that point. And then 2 is just a single factor, so just cross that. And you have y-intercept at 0, negative 2. See from this. So 0, negative 2, you have point here. And the coefficient is 1. So for the x, like the first number here is 1. So it's a positive number. If it's a positive number, you start from the top. Okay, start from the top. You go through that point, but you not pass through that one, you will turning down because it's a turning point. Okay, that become a turning point. So that's negative 1, 0. That's 0, negative 2, and that gives you what is 2, 0. Okay, you need to know where to start. Okay, you need to know where to start. So always start from the right. Okay, doesn't matter it's a cube function or a quartic or like a power 5, you always start from the right. But you look at the coefficient, whether the coefficient is positive or negative, and you decide whether you want to start from the top or start from the bottom. So you always start your graph on your right hand side. Okay, you write this here. So have a look at the next one. The next one, I want to factorize this. Okay, I want to factorize this. I will have coefficient minus 1, minus 3, minus 1, and 5. Let's try a 1. That's minus 1 times that, minus 4 times plus 1, minus 5 plus 5, 0. So that works. So that works. So x equals to x minus 1. But what you have is a minus x squared, minus 4x, and minus 5. What you can do is take the minus sign out. That is a minus bracket x minus 1, x squared plus 4x plus 5. And let's have a look at the discriminant. The discriminant is 4 squared minus 4 times 1 times 5. 16 minus 20, which is smaller than 0. So I cannot factorize anymore for this quadratic. Okay, this quadratic just stop here, and that's the fully factorized form. It's not fully factorized because I haven't really factorized the quadratic, but I cannot factorize anymore. So for this graph, I can only find out one x-intercept, which is 1, 0. Okay, what I can find is a 1, 0. I can find x-intercept at 1, 0, and I can find y-intercept at 0, 5. Okay, and where to start the graph? Always start from the right-hand side, but because I have a negative coefficient, the first number is -1. I'll start from the bottom. Okay, I'll start from the bottom. So I will go from here to here. Okay, I'll start from here. So I'll start from here and go to here. And let's say normally the graph will go down and go like this direction, but I cannot go this direction because there's no other intercepts here. I cannot turn down. So what I can do is I can't keep going forever that way. So it will look like a cubic graph. Okay, what the cubic graph looks like some shape like that is turned twice. Okay, but for this one I cannot turn down. So what I can do is going back like that. I don't know where to turn, but the graph will roughly looks like that. I cannot reach the x-intercept. I must turn before I touch the x-intercept to make sure there's no other x-intercept. Okay, there's only x-intercept is at this point 1, 0, and I have a y-intercept at 0, 5. But if you keep going like a straight line, go forever that side, which is not a cubic shape. I want to maintain that's a cubic shape. Okay, I want that looks like a cubic shape. So the cubic shape is like that, but I cannot make the turning point below the x-axis. Okay, it must be above that to make sure there's no other x-intercept. So the graph will look like this. Okay, next one is solve cubic inequalities. So the way to solve cubic inequality will be the same as solve for quadratic inequalities. So you sketch a graph and find out which part I want. So first of all, I still need to factorize this thing. Okay, so I have 1, 1, -5, and 3. So I will try 1. Give me 1. 1 times 1, 1, 1 plus 1, 2, 1 times 2, 2, 2 plus -5, which is -3, 1 times -3 plus 3, which is a 0. So what you want is x minus 1, x squared plus 2x minus 3 smaller or equals to 0. Then I have x minus 1, x minus 1, x minus 3, minus 1, and x plus 3. Because I need a positive 2. Smaller equals to 0. So you have x minus 1 squared, x plus 3, smaller equals to 0. And this means I want to sketch this thing. Okay, I want to sketch the left hand side. Okay, I want to sketch the left hand side. So I will have 1 and 0. I have -3 and 0. Intercept is 3, 0. And the equation starts from a positive coefficient. So I'll start from the right. And I have 1, 0 is the turning point here. Okay, turning point here because I have a square. Okay, so I start from the top. Okay, somewhere top here. So go to this point, but it turns here. And it passes through the y-intercept. Okay, start somewhere here. And it will go to reach the other intercept, which is here. Okay, so that point is 1, 0. That point is negative 3, 0. Here is 0, 5. And what I want smaller equals to 0. Okay, smaller equals to 0. Below x-axis, okay, below x-axis, which is from here to here. Is that everything? Is that everything? Have to think about that. Do we miss anything? Yeah? I can equals to 0 as well. Okay, so there's another point here. Okay, it can touch x-axis as well, and also below axis. So the corresponding x will be all of these x and the x for that point. So which gives me my x should belongs to, okay, all the negative numbers until negative 3 included, union, a curly bracket, and 1. Okay, close the curly bracket. Okay, a set in a union a point. Okay, a set union a point. Okay, any questions? Like this question is very easy to lose the point, like equals to 0, 1. Okay, read the question carefully. Okay, so that's how to solve inequalities for any other polynomial. So not only cubic, quartic is the same. You sketch the quartic, find out the region required, and then find the corresponding x values. Say we have polynomials higher degrees, like another one will be quartic. The quartic will be really similar to the quadratic. It got turning point form as well. So the turning point form of that is ax minus h to the power 4 plus k. Okay, we just change to the power of 2 to the power of 4, and it's exactly the same. And the way to sketch it is exactly the same. You don't need to worry about like 4. Okay, just sketch, suppose that's a quadratic, and how you sketch quadratic. The only difference between the quadratic and quartic will be quadratic is more like, we have a really like round shape bottom like that, and for quartic it's like more flat for the turning point part. Okay, that's the how it looks different, but like overall it looks pretty much the same. Okay, it looks pretty much the same. Okay, let's look at this one. I want to sketch x minus 4 to the power 4 minus 1. So I will have turning point at 2, negative 1. Okay, I will have turning point at 2, negative 1. So where's 2, negative 1? So I have 2 here, negative 1 here. Okay, this point is 2, negative 1. And you know this shape should be a positive shape, okay, like the smile face. So your graph will like looks like this. So you will have to x-intercept. You will have to x-intercept. So let's work out the xy intercept first. So when x equals to 0, f0 equals to negative 2 to the power 4 minus 1, which equals to 15. So it's a pretty high number somewhere here. So you have 0, 15 here. And when y equals to 0, x minus 2 to the power 4 equals to 1. Now you're going to take the even root. Okay, you're going to take the even root, which means same as the quadratic. You will have plus minus like equals to plus minus of root of power 4. Okay, fourth root. And then x minus 2 equals to plus minus 1. Then x can be 3 or 1. Okay, can be 3 or 1. So you will have 1, 0 and 3, 0. Okay, have 1, 0 and 3, 0. Then the shape will be this. Okay. exactly looks like a quadratic. But instead, like the bottom is a little bit flat. Okay, a little bit flat at the bottom. Okay, for the next one, I will have turning point at -1 and 4. Turning point at -1 and 4, which is here, and it's a decreasing graph like that. So you will have 2 turning points. You will have 2 turning intercepts. So first, when x equals to 0. Y equals to -2 times 1 to the power 4 plus 4, that equals to y equals to 2. Okay, so you have 0, 2, which is here. And then when y equals to 0, 2x plus 1 to the power 4 equals to 4. X plus 1 to the power 4 equals to a half. X plus 1 equals to plus minus 4th root of a half. X equals to -1 plus minus. Okay, if you want to rationalize the denominator, you need to times 3 2's on the bottom, so you need to times 8 on the top as well. So it's 8 to the 4th root over 2. Okay, 8 to the 4th root over 2. So let's say your graph looks like this. You will have -1 plus 4th root of 8 over 2, 0. You have this one is -1 minus that 0, and you have 0, 2 here. Okay, that's the graph for this one. Yeah. Which one? Oh, yes. Sorry. 4 over 2 is 2, not a half. So that is 2, that is plus minus 2, 4th root of 2, and then -1 plus minus 2, 4th root of 2. So that is -1 plus 4th root of 2, and that one is -1 minus 4th root of 2, 0. Okay. Okay, so just draw this as the quadratic, and remember when you take 4th root of each side, you will have plus minus. It will be the same for every even power. When you take even roots, you always need to put plus minus sign next to it. Okay, always needs to have the plus minus sign. Okay, now I want to sketch this graph. How many pages I have left? At least to have finish those 2 pages. Okay, so sketch this graph of the following, and I want to factorize that first. Okay, I want to factorize that first. But okay, now the good thing for this table method will be, see, you have coefficient of 1, coefficient of 0, coefficient of -2, coefficient of 0, and coefficient of 1. Okay, that's what you have. You have a power 4. And let's try a number of 1. Like what you have is 1, 1, -1, -1, and 0. Okay, that works. Okay, that works. So what your px is? Your px is x minus 1, x cubed plus x squared minus x minus 1. But it still cannot factorize this cubic because you need to go through another step to factorize this cubic. Okay, but the good thing is, let's have a look at all these coefficients. 1, 1, -1, -1. Which is those 4 numbers. You can keep going with this table. Okay, you can try another number, but use this as this, and you try to factorize. Okay, so let's try another number. Let's try -1. Let's try -1. So that will, okay, do not look at this one now. Look at the blue line, okay? The blue line will give you 1, -1 plus that is 0. That's -1. -1 times -1 is 1. 1 plus -1 is 0. So this one worked again. So your px can be factorized as x minus 1, x plus 1, and you have x squared minus 1. Okay, x squared plus 0x minus 1. Okay, now what you can do is that's x minus 1, that's x plus 1, and this is x plus 1 and x minus 1. So you have x minus 1 squared and x plus 1 squared. So you just have 2x intercept, but they're all repeated. Okay, they're all repeated. Have y-intercept at 0, 1. You have x-intercept at 1, 0. You have another x-intercept at -1, 0. And you know both of that are turning point because you have 2 factor. Okay, get 2 factor. And remember, if it's a quartic, then and it's like a really symmetrical shape. Okay, 2 of that, and the middle is here. But then that will become a symmetrical shape. Okay, that will become a symmetrical shape. You have the highest power is positive, so you will start from the positive. So that is the turning point. You turn here, and then you will turn at the middle, and then go here. So your shape will looks like a W shape. Okay, it's a W shape. And it's symmetrical. Okay, it's symmetrical because it's a quartic function, not cubic. Okay, cubic and quartic are different because it's a quartic function, and then it's like a W shape. Then that will become symmetrical. Your x-intercept is already symmetrical, and you can see a y-intercept just in the middle of those two. Then that will become like a really symmetrical shape. Okay, that's this one. This one just say you just need to know the factorized form. Okay, fully factorized form, and then think about where you will start your graph and then connect all of them. Okay, have a look at the next one. Have a look at the next one. Okay, let's try 1, -2, -3, have 4, and have 4. Think about if you do long division, you do 2 times of long division because quartic become cubic will be once, cubic to quadratic will be another time. So for factorized quartic, the advantage of this synthetic method like really appears. We can try ±1, ±4, 2, and ±4. Let's try 1. Okay, let's try 1. Have 1, 1 minus that -1, -1 minus 3 is -4. That is 0, but that become a 4. That's not worked. 1, 1, -1, -1, -4. That's not worked because the last number is not good. -1. Okay, 1 -1 minus 3. 3 times that is 0. 0 plus 4 is 4. -4 plus that 0. So that one works. But that one work is not helpful because you have a cubic here. Okay, you have a cubic here, so it needs to keep going. Okay, it needs to keep going with that. Okay, use this column number. So let's keep trying with 2 because you won't try 1 again. The 1 is not working. So let's try 2. So 1, 2 minus 3 is -1. Give you a -2. -2 minus 4 plus 4 is a 0. So this one works. Okay, this one works. So you have factor -1 and +2. So this equation will equals to x plus 1, x minus 2, x squared minus x minus 2. That will be x plus 1, x minus 2, x minus 2, and x plus plus 1. So again, you have x plus 1 squared and x minus 2 squared. Okay, that is what you have. X minus 1 squared and x minus 2 squared. So you have the point 1, 2, okay, minus 1, 0, and 2, 0, and the x-intercept is 4, y-intercept is 0, 4, and the graph will be symmetrical again. Can you see the graph will be symmetrical again? And the highest power is positive, so that is a turning point, that is a turning point. So you will have turning point like that. Okay, like this shape. It's like a W shape again, so it's symmetrical again. Have minus 1, 0, and 2, 0. So everything we learn in polynomials is require us to factorize. If we can factorize, we can do 90% of the things already. Okay? Okay, solve for the following inequalities. Okay, solve the following inequalities. Let's solve for the first one. Let's solve for the first one. I need to solve that minus x to the power 4 plus 2x cubed plus 24x squared to be greater or equals to 0. Let's take minus x squared because I have highest common factor, which is x squared. So minus x squared left with x squared minus 2x minus 24 greater or equals to 0. Minus x squared, okay, 4, 6 can make a 2. So it's x minus 6, x plus 4 greater or equals to 0. Okay, I'll ask you to factorize at home. I'm not sure if you factorize it. Okay, you have y, you have x, and then you have the intercept 3. Okay, you have 0, 0, but you have 2x, is x times x. So you have the point 0, 0 here, but that will be a turning point. And you have 6, 0, which is here, 6, 0, and you have minus 4, 0, so which is here, minus 4, 0. And you will start from the bottom. You will start from the bottom because it's a negative coefficient. The leading term got the negative coefficient. So you start from the bottom, go through there, go to touch that point, but that point is a turning point. And then it's turn again here. Okay, it's a shape like that. Okay, it's a shape like that. What you need is greater or equals to 0. So greater or equals to 0 is all this point, all of this thing here. Okay, it's all greater or equals to 0. So if that's all greater or equals to 0, all the values in between here will be possible. So x will belong to negative 4 to 6 included. Okay, negative 4 to 6 included. All the red part is greater or equals to 0, and I need the x value in between.